Question 5. The demand for Taipei Dome tickets to watch the Taiwan series is given by the function P of y equals this one, where P is the price and y is the quantity demanded. Question A. Find the interval of y on which P of y is decreasing, and both P and y are positive. So P of y is decreasing. To check whether a function is decreasing or not, we simply check its first derivative, right? If the first derivative is negative, then the function is decreasing. So we simply write down the first derivative of the function p. So p of y is 100 minus y over 10 squared. And therefore, the first derivative of it, you take derivatives, is 2 times 100 minus y over 10 and times the chain rule part, negative 1 over 10. We expect this to be negative, right? So it is saying that 100 minus y over 10 should be greater than 0. And therefore, y should be smaller than 1000. And by the nature of y, so y is a quantity, right? So it should be positive. You can also write down these equal signs. So to write or not to write are both acceptable. Okay. And then and we are also asked to find the check if p and y are positive. So you can check the inverse function of this. So p of y is 100 minus y over 10 squared, right? So if you take the square root, so root p should be 100 minus y over 10. Here, the both positive and negative are acceptable. So y in the positive case should be 100 minus root p and times 10. And on the other hand, if it is a negative case, this should be positive, right? But beware that when it is a positive case, to be specific, when your demand functions, right, is written in this form. Uh, okay, then you'll see as price is getting higher, your demand function y is getting higher as well. This doesn't make sense, right? So, for example, if you go to the market and buy an apple, and it says, "Oh, the apple costs 1,000 NT dollars," and you say, "Wow, I love it," and you buy a lot. This doesn't make sense. So, um, this case is a contradiction, and therefore, the only inverse function should be 100 minus root p. Okay, this one. And then question B, find the point elasticity when P is 100. The formula for the elasticity is given in this form. So the first form is exactly the same as what we defined in the worksheet, right? And you notice that you can also use this version. This is from the inverse function theorem, right? So recall that the derivative of an inverse function, right, is an inverse function, and the derivative of it is defined to be the derivative, the reciprocal of the derivative. So that means dy dp can be written in a form of dp dy. D, let me write in y prime p equals p prime p, the means the reciprocal of p prime y. Okay, so the epsilon, so the elasticity e over y, d prime y can now be written. Oh my god, this is y. Okay, can now be represented in p over y and what y prime p. Oh my god, this is incorrect. I must be so tired. Y p is therefore p y. Okay. And then for question B to write them in and to write down the correct elasticity, it is p over y. Oh, it seems y prime p is easier, right? So it's from here. Here, y can be written in this form. So let's use y prime p. So it should be p p. Let's represent all of them in p. So p and y is n times 100 minus root p. Okay, this is y. This is y. And times y prime p. So the first derivative will be, so here, 100. You take derivative, it becomes 0. And negative root p. Root p is p to the power of 1/2, right? So if you take derivative of it, it becomes negative 1/2 p, negative 1/2 positive root p equals p to the 1/2. So the derivative of root p become 1/2 p negative 1/2. And is a 10 and negative here. So it will be negative 10 times 1/2 p to the negative 1/2. By plugging p equals 100, you will get the result. So 10, 100 minus 10, and negative 10, 1/2, 1 over 10. And then we have 10, 10, 10, 10, 5, It's negative 1 over 18, right? If you don't like to use the derivative of its inverse function, you can also use this version. So let me show you. So the other version will be epsilon equals p over y times p prime y, right? And in question A, we see p prime y is this one, this guy. So it is p y, but y is still you should use this. So okay, y, and then p prime y is 100 minus y over 10 times negative 1 over 10. We should also check if p equals 100, y equals 10 times 100 minus root p is 900, right? So plugging in p 900, or p is 100, times 1 over 2 times here 900 over 10 is 90. 100 minus 90 is 10, and negative 1 over 10. So you can cancel them. Okay, the same result, 1 over negative 1 over 18. And then question C, the current price is 100. Does increasing the price make the revenue larger? So there are two ways to solve this. So you guys are majoring in economics, right? So you are actually economists. So when the when the elasticity is um, negative 1 over 18, you can some implication can be seen, or you can calculate this as an mathematician. So to check if increasing the price will make this larger, we check the first derivative, right? We want to find a relation between the price P and Py. So essentially, we need to take derivative of Py with respect to P. And if the result is positive, then we know increasing in P makes the revenue increase, right? Okay, so mm, d dp Py. So since our variable here is P, so we change y into P. So y is this one. This one. Okay, so n times 100 minus root p. So it would be 1000 p minus 10 p to the 3 over 2. Okay, you are ready to take derivative. So it will be 1000 minus 15 p, okay, 10 times 3 over 2, p to the 1/2. And then when p is 100, you can find it 15 times 10. So it's 850, which is positive. So as a result, an increase in price will make the revenue larger. So the solution is yes.